Alrighty, now on to congruency. So the next two questions are going to ask us to prove formally that the two triangles are congruent. Now, congruent just means that the triangles are exactly the same. They may be flipped or shown in a different way, but we've got to prove that they're the same. So there are a few rules to congruency. If three of the sides are the same, then it's congruent. It's kind of obvious. If one side, an angle, and another side is the same, that's congruent. If you've got two angles and a side, then that's congruent. If you've got three angles are the same, it's congruent. If you've got a right angled hypotenuse side, that's also congruent. Okay, so you need to have these in mind, and one of these rules will apply to some of these questions. Okay, so firstly, if you're given a triangle and it's not labeled, make sure you label it like this. We'll just label it A, B, C, the other one D, E, F. Okay, this one's kind of straightforward. We are looking for the sides that are the same, so the one with the single dash there and there, that's the same. So we'll call this, we'll say AB is equal to DE, and then the one with the double dash that are the same, that's that one and that one. We will say AC is equal to EF. And lastly, the one with the triple dash, that means that one and that one's the same, and we'll say BC is equal to DF. Once we've stated those three sides, we can see that it's going to be from the rule side, side, side. We'll come and write that down here, side, side, side. Therefore, the triangle ABC is congruent. That's when you put your three dashes, three lines. For congruency, I forgot to say triangle DEF. Okay. Now it may not be as simple as that. In some other questions where we have the triangles all combined in one diagram, and you might have to use angle properties, and we're going to do that next. Okay, now on to this question. Again, it's asking us to prove that triangle QPR, so QPR, that triangle is congruent. They've used another symbol there, that's fine, is congruent to this other triangle, which is TRS. Okay, so here is where we need to use our angle properties, and we'll go through them step by step. So the first and easy one is that these two angles are the same. We call them vertically opposite. Now writing the angles, we've got to be careful, and here we will write angle PQR is equal to angle SRT. Now, as long, my apologies, this should be PRQ is equal to angle SRT. As long as you have the R in the middle, that's where the angle is. You could rewrite this as angle QRP is equal to angle TRS. Doesn't matter as long as the R is in the center. Okay, that's the first one. The second one is alternate angles, but before we move on, we should just say that this is because it's vertically opposite. So the next one is going to be your alternate angles. Now we can use the alternate angles because in the diagram you can see these two arrows, means that those two lines are parallel. So with alternate angles, you'll use what we also known as the Z rule, which means that that angle there is equal to that angle there. Okay, so we'll just come out and write this. We will say angle PQR is equal to angle and we will say that's because it's alternate angles. If you forget the word alternate angles, just say Z rule. Okay, and then lastly, we can see another Z over here the other way, basically. That's that one there, that's a Z there, and so that means that angle is equal to that angle there. So we will write it out. We will say angle QPR is equal to angle RTS, and then we'll say alternate angles. Call it the Z rule. Okay, we're almost there. Now we need to see which one of these congruency laws apply, and we know that the three angles that we've talked about. So we'll come ahead and say that's angle, angle, angle. Therefore, triangle QPR is congruent to triangle TSR. And that's all you need to do for that.